Hello everyone, I welcome you all to the next chapter of this course. In this chapter, we shall see problems on number system. First, let us see the types of number system. The first one is international number system. This one is widely used numbering system which organizes numbers into groups of 3 digits separated by a comma, and it is commonly used in most countries except South Asia. The next one is Indian number system or Hindu-Arabic number system. This one is commonly used in countries of South Asia, but the first grouping is in 3 digits and subsequently it is grouped in 2 digits. Let us see an example for both cases. In the international number system, we can see the grouping done in 3 digits starting from the right to left. Whereas in the Indian number system, the first 3 digits are grouped together and subsequently the 2 digits are grouped, which are separated by a comma as shown here. Next, we shall see the comparison of numbers between international system and Indian system. Here we can see the value and place value of numbers. Till 10,000 both are same. Beyond that the difference starts coming. For example, 1 followed by 5 zeros is called 100,000 in international system and it is called as 1 lakh in Indian system. Similarly, 1 million is equal to 10 lakhs here and 10 million is equal to 1 crore. Further, for 100 million and 1 billion it is 10 crores and 100 crores. You can pause the video and see the difference between two numbering systems. Now let us see some examples between both the numbering systems. Let us start with this one. So this number is called 983,328. Whereas in Indian system it is read as 9,83,328. Similarly, this one is 16,169,845. Whereas here it is 1 crore 61 lakhs 69,845. And the last one, 2,365,857,659. Whereas here it is 236 crore 58 lakh 57,659. So here you can see the comparison between reading the numbers in two cases. Next we shall see face value and place value of a digit. The face value of a digit is the digit itself, irrespective of its position in the number. Whereas the place value of a digit depends on its position in the number. It is the product of digit and the value of its position. Let us see some example. For example, the number 7659, here the face value of 9 is 9, 5 is 5 and 6 is 6. Whereas the place value of 9 is 9 into 1, that is 9. And the place value of 5 is 5 into 10, 50, because it is in tens place. And similarly, the place value of 6 is 600 and the place value of 7 is 7000. Please note, whenever 0 comes in any such number, the place value of 0 in any given number is 0 at whatever place it may be. Okay, this is all about face value and place value. Next we shall see the various types of numbers, starting with natural numbers, the commonly known one. Here, this is the set of counting numbers starting from 1 and going on infinitely. They do not include any fractions, decimals or negative numbers. For example, the number starts from 1, 2, 3 and it goes on. These are all natural numbers. Next is whole numbers. These are the set of numbers that include all the natural numbers and 0. That is, it starts from 0, 1, 2, 3, 4 and it goes on like that. Next is integers. These are the set of whole numbers and their negatives included. They include positive numbers, negative numbers and 0, but do not include any fractions or decimals. So the integers are starting from minus infinity to plus infinity, all the numbers mentioned here. But it should not include any fractions or decimals. Next is even numbers. Integers that are divisible by 2 without leaving a remainder, that is 0, 2, 4, 6, 8 are all even numbers. And similarly, integers that are not divisible by 2, meaning they leave a remainder of 1 when divided by 2, that is 1, 3, 5, 7, 9 are all odd numbers. And next is prime numbers. Here these are all natural numbers greater than 1 that exactly have two distinct factors, namely 1 and the number itself. That is, it cannot be divided by any other number other than the same number as well as number 1. For example, prime numbers under 50 are given here, that is 2, 3, 5, 7, 11 and it goes on. till 43, 47. These are the prime numbers under 50. These are all well known to you, but this is just a revision before we proceed to solve the problems. Next is composite numbers. These are natural numbers greater than 1 and that are not prime, meaning they can have more than 2 distinct positive factors. This is called composite numbers. All numbers other than prime numbers. Next, perfect numbers. These are positive integers that is equal to the sum of its proper factors, excluding the number itself. For example, 6, 28, 496, etc. So the factors of 6 are 1, 2 and 3 and 6. So if you consider the numbers other than 6, then 1 plus 2 plus 3 is equal to 6. Similarly, the factor of 28 are 1, 2, 4, 7, 14 and 28. So if you ignore this 28, the sum of 1, 2, 4, 7 and 14 is equal to 28. So such numbers are called perfect numbers. Next one, co-primes or relative primes. Here two numbers whose HCF, that is highest common factor is 1, are called co-prime numbers. It means these numbers individually need not be prime, but they are prime to each other. It means they will not have any common factors other than 1. For example, 3 and 4 are pairs of co-primes. Similarly, 8 and 9. These two are divisible by 2 and 3 respectively, but they don't have any common factors other than 1. So these are called co-primes. Next is rational numbers. These are numbers which can be expressed in the form of p by q, where p and q are integers and q is not equal to 0. That is, denominator cannot be 0, so that the whole value will become infinity. Such numbers are called rational numbers. For example, 1 by 8, minus 5 by 7, 0, 6, 5, 2 by 3, etc. These are all mixed fractions or fractions. This is called rational numbers. Next is irrational numbers. These are numbers which when expressed in decimal would be in a non-terminating or non-repeating form. This is called irrational numbers. So these numbers will be going continuously. There is no repetition or no ending for these numbers. This is called irrational numbers. Next, in this figure we shall see different categories of numbers as a subset of one another. In the center we have got natural numbers which are starting from 1, followed by whole numbers which start from 0. And the next one is integers which contains both positive and negative numbers. Okay. Next is rational numbers which contains fractions, decimals as well as integers, whole numbers and natural numbers. Next is real numbers which includes all the rational numbers as well as irrational numbers like pi, root 5 or root 2. Finally, we have got the complex numbers which include both real numbers as well as complex numbers. Here we can see this 5 plus 3i where I is the imaginary part. So these are the different types of number systems represented in a single figure. Okay, finally we shall see the tests of divisibility. For divisibility by certain number, we have to meet certain conditions and criteria. Let us check the divisibility by 2 condition. Here a number is divisible by 2 if its unit digit is of any 0, 2, 4, 6 or 8. It means the unit digit should be an even number. Next, divisibility by 3. Here the sum of the digits should be divisible by 3. For example, 69 or 126, etc. Here if you see, the sum of the digits will be divisible by 3. Next, divisibility by 4. That is, if the number formed by its last 2 digits is divisible by 4. For example, 332. Here 32 is divisible by 4. Therefore, 332 is divisible by 4. Next is 116. Here 16 is divisible by 4. Therefore, 116 is also divisible by 4. Next is divisibility by 5. When its unit digit is 0 or 5. 50, 65 like that. Next is by 8. If the number found by its last 3 digits is divisible by 8. For example, if it is 120 or 432, etc. Next, divisibility by 9. When the sum of its digits is divisible by 9, it means 81, 72, etc. Here the sum of the digits will be divisible by 9. Next is divisibility by 11. If the difference between the sum of the digits at odd places and sum of the digits at even places is either 0 or divisible by 11. For example, if you take 132, the sum of the digits in odd places will be equal to sum of the digits in even places. That means the difference will be equal to 0. So it is divisible by 11. Another example is 1, 2, 3, 2. It means the sum of the digits at odd places and even places will be equal to 0. So this number is divisible by 11. So these are the certain thumb rules which we can follow to check the divisibility by different numbers. Okay, that's all with the introduction. Now we shall start solving the problems. Okay, we shall continue in the next lecture. Thank you.